The next section, 3.6, is on asymptotes of a graph. What this is all leading to is wanting to be able to graph functions. Many functions that we graph in this class do have asymptotes, so we want to remind ourselves of a college algebra concept called horizontal asymptotes and vertical asymptotes. We've already seen these slightly in the beginning of the semester. We are looking at asymptotes, which were a college algebra topic, but we're looking at them with a calculus bend. For instance, let's look at this first graph right here. When you look at the graph of 3 over x minus 2, you see that there's that dotted line at x equals 2. You see that the function approaches that line from the left and from the right, but it never actually touches that line. That line is called a vertical asymptote. So a limit in which f of x approaches infinity or negative infinity, as x approaches that value, in this case x equals 2, from the left or from the right, is called an infinite limit. So for instance, it says the limit as x approaches 2. If you remember that little negative sign, that means from the left. So as we approach 2 from the left, when we're looking at the graph, we're approaching x equals 2, our y value goes down towards negative infinity. As we approach x equals 2 from the right, as we come from the right, it looks like our y value goes up to be infinity, positive infinity. And what it says is the formal definition of a vertical asymptote. It says if f of x approaches infinity or negative infinity as x approaches c, in this case x equals 2, from the right or left, either side, either infinity or negative infinity, then you say the line x equals c is a vertical asymptote. I want to be very, very specific here. You do have to write x equals. So for instance, we would say x equals 2. That is the dotted line. That line is the vertical asymptote. So if you had more than one of them, for instance, if you had x equals 2 and x equals 4, you would have to write it as two separate equations, x equals 2 and 4. You could not write it as x equals 2 comma 4 because those aren't equations of lines, those are values for x. So you have to write them as two separate equations of lines if you ever have more than one. Okay, so how can we figure it out? How do we find infinite limits? Well, one of the things I let you guys use on this was a table for your calculator. So I'd suggest going back to your calculator table and using your calculator table to help you figure this out. Both of these, we have x values. What we're looking at is what happens when x approaches 2, and we're plugging it into the y value, the function of y equals 1 over x minus 2. So the idea is we want to look at some x values as it approaches 2 from the left, and some x values as it approaches 2 from the right. So what did we do? When we did this, when we were using numbers to the left of it, we subtracted 0.1, so that would be 1.9. Then we got a little closer by doing 1.99, and then even closer as 1.999. That would be approaching 2 from the left, which is problem A. We also did 2.1, 2.01, and then 2.001. Remember, this goes all the way back to the beginning of the semester. That would be approaching 2 from the right. So the question is, as x approaches 2 from the left, what happens? And as x approaches 2 from the right, what happens? Notice, if we tried to plug in 2, that would be 1 over 0, which is undefined. 1 over 2 minus 2 is 1 over 0. 1 over 0 is undefined. And again, for limits, we don't care what happens at that point, only near the point. So go ahead and use your table value on your calculator to figure that out. So again, I'm hitting the table. I'm typing in the function under y equals. I'm doing 1 divided by, using the fraction button, x minus 2. Hit enter. You want to start at, don't worry about that. Step, don't worry about that. Go to ask and then type in the numbers. So if I type in 1.9 and hit enter, I'm getting negative 10. If I type in 1.99, I'm getting negative 100. And if I type in 1.999, I'm getting negative 1,000. Notice these numbers are getting larger and larger, negative, so it seems like as I approach 2 from the left, I'm approaching the value negative infinity, growing without bound in the negative direction. Let's try the exact same thing from the right. Let's plug in those numbers now. If I go back in and I plug in 2.1, I'm getting 10. If I plug in 2.01, I'm getting 100. If I plug in 2.001, I'm getting 1,000. So as I get closer and closer from the right, it appears that I'm getting larger and larger, approaching infinity. So because from the left I'm approaching negative infinity, that's the answer to that problem. From the right I'm approaching infinity, we could conclude there is a vertical asymptote at x equals 2. If either of those directions approach negative infinity or infinity, I know I have a vertical asymptote. So we can just simply go back to using our charts, plugging in our tables, just like we did in the first few sections of this semester.